Okay, good morning world, good morning, evening, or whatever time you are watching this video. So, what I have done is I have completed a course in Datacamp, that is Introduction to Python. Uh, and My sister had a very weird way of learning things. Like, after completion of, so for example, she has completed class 5th, she has passed it already. She would take out the books of class 5th again and start reading. Like, if she has completed class 10th and she has passed already, like she got the grades in her hand, and after that she will go back and study the 10th books again. So means initially we used to think what she is doing, but then it has two advantages. The first is you can revise without having the pressure that someone would be evaluating you, and second, that you would be able to read that book or absorb that book faster than what you have done for the first time. So I'm trying out her way of learning in this course. So in the data camp, you can see that data camp has changed its symbol. Like previously it used to be D, C, something like that, and now it's like an alpha omega symbol. It also represent DC, like, but they have just changed the symbol and it looks more fancier now. Though inside the programming and everything looks exactly same, they have just changed the symbol. Uh, in this video, I'll do a speed run of the first course, not the whole, just the first. What to say? Introduction to Python. That's the first course. I'll try to have a speed run of it. It is of 4 hours, and last time it took me I think 5 hours to complete it. So the course I'm enrolled in Datacamp is like data scientist with Python, and it's a huge course. Like it consists of 88 hours of study, like 23 projects, and it should be completed in 88 hours. Okay, so that's the big what to say target, which I would not complete. I would say in the start of the video that I will not complete the whole data science career with Python, because I have already enrolled in an edX Harvard thingy. So that's edX Harvard course of data science. I have enrolled there already, and I would like to complete that one first because that is like more related to my field, which is research and development in life science. So I'll complete this data science course, which is of 1.5 year. Sorry, it's not R basis, that whole certificate. Uh, yeah, that professional certificate in data science. So this certificate is of 1.5 year. I have enrolled it already, and it recommends me to read for 2 to 3 hours per week. There are some projects which require 20 hours per week, but every week it should be 2 to 3 hours, and I'm willing to spend more time to complete this, which would be helpful in both either PhD as well as the research jobs. Uh, so that's the program I'm looking forward to. But uh, before enrolling into this degree, I have already started the data science with Python. So only for this video and this particular refreshment, we will do the first part of it, that is introduction to Python, which I have completed already, but I'll do it again. And in this video, I will not be explaining everything in detail because I have done that already in my other channel. I should keep that link in description, or it's not worth it to go there and check all the videos in case if you need any explanation of how I have done that. I have struggled a lot while making those videos, so I have kept on trying and then got the solution. And sometimes I cheated. I actually saw the solution. But so if you complete that introduction in Python, that's the first one. Then you can move on to intermediate in Python, which I'm not going to continue. I'll continue that data science professional degree. Uh, Probably I'll come back to Python after completion of everything in R. Uh, yeah, someone recently told me that I should stop saying that, but it keeps on coming. Then it'll be data analyzing TV data. That's a project. Projects takes like 20 hours a week. Then data manipulation with pandas. And if you see all the 23 courses, it goes like the Android market app on Google Play. Then joining data with pandas, data manipulation with Python, GitHub, it's a repository if I'm pronouncing right. Then introduction to data visualization. These all the things I would require in future, but I would make the R as my basic and then go on to Python, because I found Python very easy. Like I did struggle there, but I found it very easy. Then more toolboxes, then more assessment, intermediate data visualization. If you like to join this course, I will just keep that description in the link as well. And on my website I have shown that if you have a Visual Studio subscription, you can have this whole course for free for 2 months. But in 2 months definitely you won't be able to complete the whole thing, and there is no point in downloading, because the videos don't make much sense if you don't practice. And Datacamp is all about you keep on practicing the skills again and again and again with different examples. So like exploratory data in analysis, analyzing policies, activities in Panda, statistical thinking. Statistical thinking, I have done like 2 days workshop with University of Queensland, I guess. University of Queensland in collaboration with Griffith University. That was interesting. Then supervised learning, kind of machine learning things. Then unsupervised learning, and then machine learning. Okay, I need all these topics, cluster analysis in Python, but not now, later on. And then finally you'll get a statement of accomplishment. The thing is, Datacamp is mostly used for practicing your skills, and these certificates is not accredited. So that's the only reason I have joined this course at HarvardX, because this certificate is accredited, means it has value somewhere. Whereas data science, though you can say yes, I know this, but there is no certification. And somewhere one of my professors said that education is free, you only pay for the degree, and that's what this model is at edX. So if you need to learn, you can enroll it for free, do the whole course for free. Only if you need the certification, you have to pay the price, which they are charging like Australian $1,000. But since I'm currently jobless, I'll probably go for asking for scholarship if they can give me. Like scholarship is like 90% discount, but then the process is very different. You have to go to you have to enroll each and every program separately. Means I have to enroll in R basic first, then visualization, then enroll in probability. I have to enroll each and every course, and for each course I have to write like 2,500 word essay that why I would need this scholarship, why I would need to learn that, and what are my future prospects if I learn this course. Like, so there'll be 3 essays of 2,500 word each. which I would be writing in future. But first I would be trying to complete as much as I can, and then to get the certificate, either I can do a revise course as I'm doing today for this Python, or I can actually jump into paying that amount if I have the money. Like $1,000 investment, that's a good investment, but then currently I don't have that in my pocket right now. So I'll see what I can do next year. If I get another small scale job, I would pay for that course, or most probably I will go for the scholarship. Oh, that's in the future. Today we'll focus on this one. So out of the whole 23 courses and 6 projects, I would go for the first one, that is Introduction to Python, and hopefully I can do it, a little bit quicker than my previous courses, means my previous thing. So let's go there. So that's the course description. If you need, you can join the course for free, you can join the Datacamp for free anyway for the practice of first unit and everything. But then if you go to my website, that's tapeshdongre.com, and go in the information section, or I should keep that link there, like Datacamp free for 2 months if you have the Visual Studio option. So I'll keep this article in the description below, but in future if you miss this article, it will be in my information section, and information section, either you can search the article or just scroll down to where it says like Datacamp 2-month access free. So that's one of the option. Or if you have a university affiliation, then you can have, means from a GitHub account, you can go for like 3 months of Datacamp free. So I'm using the same free version here, which will end soon, like in a month or two. No, in a month, because I have used it for a month already. So let's replay the course finally. So much Bakar. Is the recording still going on? And yes, it is. So we will see Hugo again. Actually, if you see the bars below, they are all blue, but they were white before, and then they used to slowly turn blue. And before starting the course, we usually see the whole course outline, that what we'll be studying. Python basics, then Python list, functional packages, and NumPy. NumPy was the most difficult one for me. So reset course progress. Are you on to reset? Yes. Okay. So now you can see that instead of all the blue lines, it's all blank. And we'll be doing this course from the start. So, okay, let's play.
Hi, my name is Hugo.
Hello,
and
Hugo.
I'll be your host for Introduction to Python for Data Science.
Thank you.
I'm a data scientist and educator at Datacamp, and host of the Data Frame podcast, which you must check out. In this course, you will learn Python.
Host of which podcast?
In this course, you will learn Python for Data Science through educator at Datacamp, and host of the Data Frame podcast, which
Data Frame podcast. Okay, I did not know that. Wow, that's a podcast. Okay, I'll go for it. First time I did not pay attention to details. Like, this is cool.
which you must check out. In this course, you will learn Python for data science through video lessons like this one and interactive exercises. You get your own Python session where you can experiment and try to come up with the correct code to solve the instructions. You're learning by doing while receiving customized and instant feedback on your work. Python was conceived by Guido van Rossum. Here you can see a photo of me with Guido. What started as a hobby project soon became a general purpose programming language. Nowadays, you can use Python to build practically any piece of software. But how did this happen? Well, first of all, Python is open source. It's free to use. Second, it's very easy to build packages in Python, which is code that you can share with other people to solve specific problems. Throughout time, more and more of these packages specifically built for data science have been developed. Suppose you want to make some fancy visualizations of your company's sales. There's a package for that. Or what about connecting to a database to analyze sensor measurements? There's also a package for that. People often refer to Python as the Swiss Army knife of programming languages, as you can do almost anything with it. In this course, we'll start to build up your data science coding skills bit by bit, so make sure to stick around to see how powerful the language can be. Currently, there are two common versions of Python, version 2.7 and 3.5. Apart from some syntactical differences, they are pretty similar.
Actually, because M1 chip is being released this month or a month before, you have 3.9.1 Python as well, which runs on that M1 chip of Mac.
But as support for version 2 will fade over time, our courses focus on Python 3. To install Python 3 on your own system, follow the steps at this URL. Now that you're all eyes and ears for Python, let's start experimenting. I'll start with the Python shell, a place where you can type Python code and immediately see the results. In Datacamp's exercise interface, this shell is embedded here. Let's start off simple and use Python as a calculator. Let me type 4 plus 5 and hit enter. Python interprets what you typed and prints the result of your calculation, 9. The Python shell that's used here is actually not the original one. We're using IPython, short for interactive Python, which is some kind of juiced up version of regular Python that'll be useful later on. IPython was created by Fernando Perez and is part of the broader Jupyter ecosystem. Apart from interactively working with Python, you can also have Python run so-called Python scripts. These Python scripts are simply text files with the extension .py. It's basically a list of Python commands that are executed almost as if you are typing the commands in the shell yourself, line by line. Let's put the command from before in a script now, which can be found here in Datacamp's interface. The next step is executing the script by clicking Submit Answer. If you execute this script in the Datacamp interface, there's nothing in the output pane. That's because you have to explicitly use print inside scripts if you want to generate output during execution. Let's wrap our previous calculation in a print call and rerun the script. This time, the same output as before is generated. Great. Putting your code in Python scripts instead of manually retyping every step interactively will help you to keep structure and avoid retyping everything over and over again if you want to make a change. You simply make the change in the script and rerun the entire thing. Now that you've got an idea about different ways of working with Python, I suggest you head over to the exercises. Use the IPython shell for experimentation and use the Python script editor to code the actual answer. If you click Submit Answer, your script will be executed and checked for correctness. Get coding and don't forget to have fun.
Don't forget to have fun. Okay, example, do not modify. So that's the script. If you need to read it, you can read it. I have read it already. I'll just jump onto the experimentation. Print the sum of 7 and 10. Print command and 7 plus 10. Run code. Yahoo! Submit answer. Okay. Control Shift Enter. Where to use Python? Everywhere. I'm not even reading it because I have done it previously, but if you need to read it, you can just pause the video and see where you can. You can check that. You can add comments. Okay, add the comment addition. Okay, this is a very stupid exercise. So when I write anything in hashtag, it won't be executed. See, it's the same thing except it's written addition. It's not executable command. So submit answer. Control Shift Enter. Okay, I should practice that. Practice this as a calculator. Like, if you need, you can read everything. I'll just hit on to practice, and if I get stuck, I'll come back to it. So how much is 100 worth after 7 years? In a 10% return. Print $100. Shift the bucket 8, that's multiplication, into 1.1, and we will raise to so raise to would be star 7. That's the formula. Run code. That's the amount. Let's submit. Okay, I should do Control Shift Enter. Enter. Should I go like full screen? F11 is full screen.
Well
Yes.
done and welcome back. It's clear that Python is a great calculator. If you want to do more complex calculations though, you will want to save values while you're coding along.
Yeah.
You can do this by defining a variable with a specific case-sensitive name. Once you create or declare such a variable, you can later call up its value by typing the variable name. Suppose you measure your height and weight in metric units. You're 1.79 meters tall and weigh 68.7 kilograms. You can assign these values to two variables named height and weight with an equal sign. If you now type the name of the variable height, Python looks for the variable name, retrieves its value, and prints it out. Let's now calculate the body mass index, or BMI, which is calculated as follows, with weight in kilograms and height in meters. You can do this with the actual values, but you can just as well use the variable's height and weight, like here.
Okay.
Every time you type the variable's name, you're asking Python to reference the actual value of the variable. Weight corresponds to 68.7 and height to 1.79. Finally, this version has Python store the result in a new variable BMI. BMI now contains the same value as the one you calculated earlier. In Python, variables are used all the time. They help to make your code reproducible. Suppose the code to create the height, weight, and BMI variables are in a script like this. If you now want to recalculate the BMI for another weight, you can simply change the declaration of the weight variable and rerun the script. The BMI changes accordingly because the value of the variable weight has changed as well. So far, we've only worked with numerical values, such as height and weight. In Python, these numbers all have a specific type. You can check out the type of a value with the type function. To see the type of our BMI value, simply write type and then BMI inside parentheses. You can see that it's a float, which is Python's way of representing a real number. So a number which can have both an integer part and a fractional part. Python also has a type for integers, int, like this example. To do data science, you'll need more than ints and floats though. Python features tons of other data types. The most common ones are strings and booleans. A string is Python's way to represent text. You can use both double and single quotes to build a string, as you can see from these examples. If you print the type of the last variable here, you see that it's str, short for string. The Boolean is a type that can either be true or false. You can think of this as yes and no in everyday language. Booleans will be very useful in the future to perform filtering operations on your data, for example. There's something special about Python data types. Have a look at this line of code that sums 2 integers, and then this line of code that sums 2 strings. For the integers, the values were summed, while for the strings were pasted together. The plus operator behaved differently for different data types. This is a general principle. How the code behaves depends on the types you're working with. In the exercises that follow, you'll create your first variables and experiment with some of Python's data types. I'll see you in the next video to explain all about lists. Let's get you coding. And I can't wait to see you in the next chapter, where you'll build even more awesome Python chops.
Okay. Enter. Create a variable saving with the value 100. So like in time, I have learned to code very differently. Like I'm building up my own thing now. So first I write the value and then it will be saved in savings, savings. So like first I write the value and then write the variable. So that's the pattern I follow. You can change your pattern. You can write savings first and then equal to 100, that kind of stuff. So print savings. Did I write spelling mistake? savings, yeah. No, Python does lot with spelling mistakes, comma, or if you forget the bracket, it doesn't run. Yes, now it's running. Submit answer. Yay, next. Create a variable growth multiplier. That's my style. First I'll write the code and then put it in the result. So that will be savings multiplied by growth multiplier raised to 7, and this will be saved in result. Same answer. Create a new string. Okay, just string. And to keep this as a string, we need to include it in a inverted commas. and you have to save this in the variable desc. Okay, create a variable profitable with the value true. This will be saved in profitable variable. Actually, even after running, it won't print anything because probably I did spelling mistake again. DSC COMPOUND INTE. I'm definitely not good with spelling mistakes. Sorry, spellings. Okay, it's better to type type a typeb. Just to check what are they. mypec. Okay, so a is a float. Okay, these two options. B is a string and C is Boolean. So this will be the answer. Submit answer. Calculate the product of saving and growth multiplier and store in year 1. Okay, assigned product of growth. Okay, year 1. Only this time I'm not going through my method. Growth multiplier. Savings multiplied by growth multiplier. It will be saved in year 1. Calculate the sum of double disk will have actually this and double this is just like string, so it will be pasted together. Yeah, it's just compound interest. What's the use of double disk? Oh, I have to print type of the year. T by PE and then double close the bracket. Okay, so it's a float. Conversion. Convert a variable by string to a float and store this. Hit run code to run the code, trying to understand the error message. Line 6 has error. Print I started saving this and now the result. The error must be string, not integer. Okay. Fix the code such that the printout runs without error. To use function string to convert variables into string. Oh, okay. str open bracket close bracket, so it will be converted into string, then str open bracket close bracket. So here it will be converted, the savings will be converted into string and will be pasted here. Run code. Yes, convert pi string into float. Pi underscore string, that will be converted into float, float. So that's the code for it, and it will be saved in pi underscore float. So this pi string would be converted into float and then it will be saved into pi float. Yeah, nothing will happen because I didn't print it. What's this? Can Python handle everything? Now you know something. Do instruction, possible answers. Okay, you just have to copy and paste and see if it can run everything. Probably this is the wrong one. Yeah, because number 2 is, it's not a string. I'll tell you what the correct answer would be. In that, if you just convert this into string or else use inverted commas there. Yeah, it ran. See? So this is the wrong. True plus false equal to 1. That's addition of 2 Boolean will be 1. So this is the wrong one. Five-star rating. Okay, Hugo, I'll take a break and then come back. Like, we have completed the first, chapter. Will be on second chapter. Second chapter is also of 1 hour. Third chapter is also of 1 hour. But the fourth chapter is of 2 hours. Sorry, 2 hours. What? How the course is of 4 hours then? Not good. I'll be back. So somehow every YouTuber recommends honey. I would recommend honey tea. Yeah, they recommend software honey, I know, for discounts, but I don't have the sponsorship. I'll just recommend the ginger honey tea or simple honey tea. That's my poison. Like, I have recently learned that the proper way of using a tea is like you dip it, and then if you have a saucer and cup, then you roll that over your spoon. I'm not sure this is in camera or not. Yeah, you roll that over your spoon and then squeeze it with this thread. Like all the tea should fall or something like this. And then keep the spoon and the tea thingy in the saucer separately. So that's the proper way, and I don't usually do that, but let's do it anyway. And keep the spoon separately. So, my beverage is ready. Hugo, let's do it. Did I drop something? Oh, I have to clean it. Or else there'll be ants. Ants love sugar. Actually, Australian ants don't love sugar. They like honey, but then they don't consume sugar for some reason. They are indicting maybe. Or probably the Australian sugar is so processed that even ants don't consume it. Hugo, let's listen to you.
Welcome back.
Oh, first I'll check if it's recording or not. Yes, it's still recording. How big the file would be? Where is OBS recording? It's of 1 GB already. So that's the file of 1 GB already, because no, that's not the file. This should be the file, STS. I'm not sure. Probably it will complete record and then save. Okay, anyway, hopefully it's been recorded. Let's listen to Hugo.
Welcome back, aspiring Pythonista.
Thank you.
By now, you've played around with different data types, and I hope you've had as much fun as I have. On the numbers side, there's the float to represent a real number, and the int to represent an integer. Next, we also have str, short for string, to represent text in Python, and bool, which can be either true or false. You can save these values as a variable, like these examples show. Each variable then represents a single value. As a data scientist, you'll often want to work with many data points. For example, if you want to measure the height of everybody in your family and store this information in Python, it would be inconvenient to create a new Python variable for each point you collected, right? What you can do instead is store all this information in a Python list. You can build such a list with square brackets. Suppose you asked, your two sisters and parents for their height in meters. You can build the list like this. Of course, also this data structure can be referenced with a variable. Simply put the variable name and the equal sign in front, like here. A list is a way to give a single name to a collection of values. These values, or elements, can have any type. They can be floats, integers, booleans, strings, but also more advanced Python types, even lists. It's perfectly possible for a list to contain different types as well. Suppose, for example, that you want to add the names of your sisters and parents to the list so that you know which heights belong to whom. You can throw in some strings without issues. But that's not all. I just told you that lists can also contain lists themselves. Instead of putting the strings in between the numbers, you can create little sublists for each member of the family. One for Liz, one for Emma, and so on. Now you can tell Python that these sublists are the elements of another list that I named fam2. The little lists are wrapped in square brackets and separated with commas. If you now print out fam2, you see that we have a list of lists. The main list contains 4 sublists. We're dealing with a new Python type here, next to the strings, booleans, integers, and floats you already know about. The list. These calls show that both fam and fam2 are lists. Remember that I told you that each type has a specific functionality and behavior associated? Well, for lists, this is also true. Python lists host a bunch of tools to subset and adapt them. But let's take this step by step and have you experiment with list creation first. Go get it.
Go get it. Okay, Hugo. Create a list area. That contains area. Create a list areas that contains area of the hallway. Hall ki kit live bed yeah. Finish the code that create the area list. Yeah. Select the valid list. Yeah, I think all the three will be. Let's check. And this is list of list. Control C, Control V. Oh, this won't be valid because A is in. Yeah, it should be valid. Yeah, all the three. A list of lists. Finish the list so that it contains bedroom and bathroom. Make sure. Enter. Even if I miss a single comma, it will show me error. I have learned that. Okay, something wrong. Yeah, as I said, even if I miss a comma, it won't do it. Oh, I forgot this. Print. It should be class, yeah. Class of list. Yoo-hoo! I'm getting quicker.
After you've created your very own Python list, you'll need to know how to access information in the list. Python uses something called an index to do this. Let's have a look at the fam list again. The first element in the list has index 0. The second element has index 1, and so on. Suppose that you want to select the height of Emma, the float 1.68. It's the fourth element, so it has index 3. To select it, you use 3 inside square brackets. Similarly, to select the string dad from the list, which is the 7th element in the list, you'll need to put the index 6 inside square brackets. Now, the fact that the index starts at 0 is called zero indexing. You can also count backwards using negative indexes. This is useful if you want to get some elements at the end of your list. To get your dad's height, for example, you'll need the index -1. These are the negative indexes for all list elements.
0 from here.
This means that both these lines return the exact same result. Apart from indexing, there's something called slicing, which allows you to select multiple elements from a list, thus creating a new list. You can do this by specifying a range using a colon. Let's first have another look at the list and then try this piece of code. Can you guess what it will return?
Yeah.
A list with the float 1.68, the string mum, and the float 1.71, corresponding to the 4th, 5th, and 6th elements in the list, maybe? Let's see what
No.
the output is. Apparently, only the elements within index 3 and 4 get returned. The element with index 5 is not included. In general, this is the syntax. The index you specify before the colon, so where the slice starts, is included, while the index you specify after the colon, where the slice ends, is not. Remember this.
Remember
With
that.
this in mind, can you tell me what this call will return? You probably guessed correctly that this call gives you a list with 3 elements, corresponding to the elements with index 1, 2, and 3 of the fam list. You can also choose to just leave out the index before or after the colon. If you leave out the index where the slice should begin, you're telling Python to start the slice from index 0, like this example. If you leave out the index where the slice should end, you include all elements up to and including the last element of the list, like here. Now it's time to head over to the exercises, where you'll continue to work on the list you've already created yourself. You'll use different subsetting methods to get exactly the pieces of information you need. Time to jump back into learning by doing.
When Hugo said, remember, it was just like the series where androids take over the world, and then the word remember, it keeps on coming. Like I forgot the name of the series, but it was on HBO. If you know it, just type it in the comment below what that series is called. There was a movie with the same series name. Okay, now I have to Google it. No. I'll keep that question for you. Just type it in the comment below what series it was. Subset and conquer. Print out the second element. Second element would be 0, 1, 1. Print out the last element, -1. Print out the area of the living room. What's the living room? Okay. 0, 1, 2, 3, 4, 5. You. Eat, sleep, rave, repeat. Sum of kitchen and bedroom area. Eat underscore sleep area is equal to sum of the areas using combination of list, subsetting and variable alignment. Create a new variable eat sleep area that contains sum of the area of kitchen and the areas of bedroom. So it like by areas, which element? Kitchen. 0, 1, 2, 3 plus areas of bedroom. -1, 2, 3, 4. -4. Either it will be -4 or 0, 1, 2, 3, 4, 5, 7. print eat sleep area run code. Should be the case. Come on. -3, -1, -2, -3. Okay, -3. EAT underscore SLEEP underscore AREA. Okay, if I keep it in bracket, it will be a list. If I keep it open, it will be a variable. Yes. So now eat sleep area is not a list, it's a variable. I got it. Blessimo. I don't know what it means. My list start and end. Okay. Use slicing to create a list downstairs. First, I should write the code and then keep it there. That's easy. But okay, I'll follow the traditional method. Downstairs equal to AS areas first 6 elements. So nothing to 5 means blank is to 5. It will have first 6 elements. Upstairs last 4 elements. Up STA -1 -2 -3 -4 -4 is to all. Oh, it will be -5 is to all because first is included. Now -4 into all. So -4 is included and all. -4 is to all does not exist. How to write that code? Okay, I didn't put that into areas. Is equal to AREAS. Yeah. Yeah, the last one is not included, so it will be 6. So if I keep 6, it will be first 6 element. The last one is not included, yeah. Okay, in the video, you go first, discuss that syntax. Create downstairs again. Alright. Oh. So in the previous one, I should have written starting and ending point. I directly used. Is to 6. Actually, in the previous one, I should have written downstairs is equal to areas 0 to 6. So 0 to 6 and is to 6 will give the same thing. If you want to check, we can do that. Let's cut this code for a while. Okay, let's print it. Probably that stupid code. But yeah, they both will give the same values if we print. Can't explain it. Okay, subsetting the list of list. Two comma 0. Two comma 0 will give D. Let's check it out. Okay, so I expect 2 comma 0 will give D. It gave G. Oh yeah, 0 1 2 2 comma 0 G. So 2 comma, this will print, wait, before pasting it, we'll see what it will get. 2, so 0 1 2 2 comma all elements till 2 0 1 2. Or it will print 0 1 2. 2 is not included. It will print G and H. Let's see. Yeah. Can do subsetting by adding square brackets. Okay. What will house -1 and 1 return? First let's print house. So what will house -1? I don't know what will return. Oh, so -1 it started from behind, and then 1 it will be 0 1. Okay, after answer I can know what it will return, but initially I didn't understand what the question was. So it will have a float that's integer plus a decimal, so it will have a float of kitchen. No, float of last one. What is the last one? Float of bathroom area. Yeah. Here you go.
Wow, you're doing super well.
I know, I'm doing
So
this for
now,
a second time.
after creation and subsetting, the final piece of the Python lists puzzle is manipulation. These are ways to change elements in your list, or to add elements to and remove elements from your list. Changing list elements is pretty straightforward.
Yeah.
You use the same square brackets that we've used to subset lists, and then assign new elements to it using the equals sign.
Okay.
Suppose that after another look at fam, you realize that your dad's height is not up to date anymore, as he's shrinking with age. Instead of 1.89 meters, it should be 1.86 meters. To change this list element, which is at index 7, you can use this line of code. If you now check out fam, you'll see that the value is updated.
Okay.
You can even change an entire list slice at once. To change the elements Liz and 1.73, you access the first two elements with 0:2, and then assign a new list to it. Do you still remember how the plus operator was different for strings and integers? Well, it's also different for lists. If you use the plus sign with two lists, Python simply pastes together their contents in a single list. Suppose you want to add your own name and height to the fam height list. This will do the trick. Of course, you can also store this new list in a variable fam_ext, for example. Finally, deleting elements from a list is also pretty straightforward. You'll have to use del here. Take this line, for example, that deletes the element with index 2, that is, Emma, from the list. If you check out fam now, you'll see that the Emma string is gone. Because you've removed an index, all elements that came after Emma moved over by one index. If you run the same line again, you're removing the element at index 2, which is Emma's height, 1.68 meters now. Understanding how Python lists actually work behind the scenes becomes pretty important now. What actually happens when you create a new list, X, like this? Well, in a simplified sense, you're storing a list in your computer memory and store the address of that list, so where the list is in your computer memory, in X. Now this means that X does not actually contain all the list elements. It rather contains a reference to the list. For basic operations, the difference is not that important, but it becomes more so when you start copying lists. Let me clarify this with an example. Let's store the list X as a new variable Y by simply using the equals sign. Let's now change the element with index 1 in the list Y like this. The funky thing is that if you now check out X again, the second element was also changed here.
Oh.
That's because when you copied X to Y with the equals sign, you copied the reference to the list, not the actual values themselves. When you're updating an element in the list, it's one and the same list in the computer memory you're changing. Both X and Y point to this list, so the update is visible from both variables. If you want to create a list Y that points to a new list in the memory with the same values, you'll need to use something other than the equals sign. You can use the list function like this, or use slicing to select all list elements explicitly. If you now make a change to the list Y points to, X is not affected. If that was a bit too much to take in, don't worry. The exercises will help you understand list manipulation and the subtle inner workings of lists. I'm sure you'll do great.
Create the areas list. We. Update the areas in bathroom. Areas, what's bathroom? Three minus 3 is equal to 9.5. Just checking if I did it right. Yeah. Both are 9.5 now. Update the areas of bathroom to be 10.5. So code is wrong. So code is right. I did the manipulation wrong. So we just wanted to change this one as .5. Yes, so 10.75, now 10.5. Last area is changed to 10.5. Similarly, areas of living room. What is living room? This one. 20, 0, 1, 2, 3, 4, 5. Five is equal to I just have to change that string. So string is 0, 1, 2, 3, 4. As chill zone. Just to test. If both the changes have been done or not. Yes, it changed to chill zone here and then changed to 10.5 as well. Yes, it's done. So Control Shift Enter. Okay, use the plus operator to paste list pool house. Okay. Areas 1 is areas plus areas 2 is areas 1 plus garage. Carriage. The print is only for my checking. Yeah. Okay, I didn't need to do this. Control Shift Enter. Finally, you can also remove elements from list. Oh, I can use semicolon here. The semicolon is used to place commands on the same line. The following two, okay, command 1, command 2, yeah, for 2 lines, okay. Which of the will do job for us? String down. Okay, what is the job? Finally, you can also remove elements. You can do with delete statement. There was a mistake in the multi-one lottery and NumPy. So now you decided to remove the corresponding string and float. फर्स्ट वन से सिर्फ 2 चीज़ें हटेंगी. Probably this one. It will start from minus. Oh, okay, there is areas here. So pool house won't be there. So pool house is minus 2, 3, 4. Minus 4 and minus -4 and -3 ऐसा कुछ है. टेन एंड 11 से क्या जाएगा? ओह, 10 एंड 11 काम नहीं करेगा क्योंकि हम 10 जब डिलीट करेंगे उसके बाद जब 11 पे जाएंगे तो 11 would be some other element. Delete 10 and 10 काम करता. डिलीट 3 एंड 4 में भी सेम दिक्कत है. -4 से -2. -4 1 2 3 4. हाँ, -2 इंक्लूडेड नहीं होगा. -4 से -2 इज द राइट आंसर. सबमिट आंसर. Inner workings of list. Change the second command that created the variable areas copy. Explicitly copy areas. Yeah. So without this semicolon, if we run it, there'll be change. Like 11.25 is changed into 5. But if I keep this line of code where I'm copying all the elements of areas into this one, then if I run code, then there are no changes. 11.25 is equal to 11.25. So instead of all elements, if I used the whole function, then also it should work. No. Yeah. So either list or the double dot, anything should come. Chapter 2, I will rate it 5-star. And we'll take another short break. Hugo, pause. Another short break and I'll be back. Birds are shouting a lot. Oh, budgies. Why are you inside? Baby. Oh, baby. What are you doing? Puppy. Oh, puppy. Come on. So that's a calm bird. His name is Puffy. He's seeing the setup for the first time. He don't know what to do. We'll get back. Hello, Puffy. You want to go there? Who? Puffy. So one of the weird challenge I took is drinking 10 liters of water in a day. I'm not sure I'll be able to finish or not because I already drank 3 to 4 glasses of water, and means I'll show you like the whole bottle is only this much finished. This is of 10-liter big bottle. So I'm not really sure I would be able to complete that whole thingy. But let's see. My plan is to keep on drinking. Okay, it's just 2 hours in the morning for me, and there are like 12 hours. Yeah, almost 12 hours remaining. If I drink at least 2 glasses of water per hour, hopefully I'll be able to finish it, but it looks like a very big challenge. Okay, another glass down. Probably I need to pee. Hugo, I don't feel like completing you, but I'll try. Okay, you go. This break was bigger than expected. Let's start.
In this video, I'm going to introduce you to functions. Once you learn about them, you won't be able to stop using them.
Just checking if the recording is still going on. Yes, the recording is still going on. That's good.
I sure can't. Functions aren't entirely new for you, actually. You've already used them. Type, for example, is a function that returns the type of a value. But what is a function? Simply put, a function is a piece of reusable code aimed at solving a particular task. You can call functions instead of having to write code yourself. Maybe an example can clarify things here. Suppose you have the list containing only the heights of your family, fam, and say that you want to get the maximum value in this list. Instead of writing your own piece of Python code that goes through the list and finds the highest value, you can also use Python's max function. This is one of Python's built-in functions, just like type. We simply pass fam to max inside parentheses. The output makes sense, 1.89. The highest number in the list. Max worked kind of like a black box here. You passed it a list, then the implementation of max, that you don't know, did its magic and produced an output. How max actually did this is not important to you. It just does what it's supposed to, and you didn't have to write your own code, which made your life easier. Of course, it's possible to also assign the result of a function call to a new variable, like here. Now, tallest is just like any other variable. You can use it to continue your fancy calculations. Another one of these built-in functions is round. It takes two inputs. First, a number you want to round, and second, the precision with which to round, which is how many digits after the decimal points you want to keep. Say you want to round 1.68 to one decimal place. The first input is 1.68. The second input is 1. You separate the inputs with a comma. But wait, there's more. It's perfectly possible to call the round function with only one input, like this. This time, Python figured out that you didn't specify the second input and automatically chooses to round the number to the closest integer. To understand why both approaches work, let's open up the documentation. You can do this with yet another function, help, like this. It appears that round takes two inputs. In Python, these inputs, also called arguments, have names, number and n digits. When you call the function round with these two inputs, Python matches the inputs to their arguments. Number is set to 1.68 and n digits is set to 1. Next, the round function does its calculations with number and n digits as if they are Python variables in a script. We don't know exactly what code Python executes. What is important, though, is that the function produces an output, namely the number 1.68 rounded to one decimal place. If you call the function round with only one input, Python again tries to match the inputs to the arguments. There's no input to match to the n digits argument though. Luckily, the internal machinery of the round function knows how to handle this. When n digits is not specified, the function simply rounds to the closest integer and returns that integer. That's why we got the number 2. Now, how was I so sure that calling the function with a single input would work? Well, in the documentation, there are square brackets around the comma and the n digits here. This tells us that you can call round in this form as well as in this one. In other words, n digits is an optional argument. Actually, Python offers yet another way to show that a function has optional arguments, but that's something for the exercises. By now, you have an idea about how to use max and round, but how could you know that a function such as round exists in Python in the first place?
Google it.
Well, this is something you'll learn with time. Whenever you're doing a rather standard task in Python, you can be pretty sure that there's already a function that can do this for you. In that case, you should definitely use it. Just do a quick internet search and you'll find the function you need with a nice usage example. And there is, of course, Datacamp, where you'll also learn about powerful functions and how to use them. Get straight to it in the interactive exercises, and I'll see you back here soon.
Print type. Stew. Use print in combination with type to print the type of variable. Print in combination with type to know what is variable 1. Print in combination with length to know variable 1. Convert variable 2, which is true, to an integer. Out2 will become int of variable 2. I just wanted to check what it is. Okay, true is 1. Okay, false is 0 and true is 1. Use the shell to open up complex. Help complex. Wow. Imaginary and real. Imaginary is optional. Complex, real and imaginary. Defaults to 0. It is not default to 1, it is defaults to 0. It's an optional one. Continue. Sorted. Okay, what does it say? You have to look sorted. 3 arguments: attribute, key, and reverse. use plus to merge the content of first and second. Full equal to in descending order. That means reverse equal to true. I think so. In this exercise, you'll only have to specify iterable and reverse, not key. In the first input, your pass sorted will be matched to the iterable. But what about the second input? To tell Python you want to specify a reverse without okay, sorted लिखते कैसे हैं? Key equal to none. I can add to list. Line 9. SOTED okay, rotate तो फुल है फिर मैन कैपिटल ये कैपिटल स्मॉल में भी दिक्कत है जीप झंडबाजी है ये नेक्स्ट
Built-in functions are only one part of the Python story. You already know about functions such as max to get the maximum of a list, len to get the length of a list or a string, and so on. But what about other basic things such as getting the index of a specific element in the list or reversing a list? You can look for built-in functions that do this, but you won't find them. In the past exercises, you've already created a bunch of variables. Among other Python types, you've created strings, floats, and lists, like the ones you see here. Each one of these values or data structures are so-called Python objects. This string is an object. This float is an object. But this list is also, you got it, an object. These objects have a specific type that you already know: string, float, and list. And of course, they represent the values you gave them, such as Liz, 1.73, and an entire list. But in addition to this, Python objects also come with a bunch of so-called methods. You can think of methods as functions that belong to Python objects.
Okay.
A Python object of type string has methods such as capitalize and replace, but also objects of type float and list has specific methods depending on the type. Enough for the theory now. Let's try to use a method. Suppose you want to get the index of the string mum in the fam list. Fam is a Python object with the type list and has a method named index. To call the method, you use the dot notation like this. The only input is the string mum, the element you want to get the index for. Python returns 4, which indeed is the index of the string mum. I called the index method on the fam list here, and the output was 4. Similarly, I can use the count method on the fam list to count the number of times 1.73 occurs in the list.
Wow.
Python gives me 1, which makes sense because only Liz is 1.73 meters tall. But lists are not the only Python objects that have associated methods. Also floats, integers, booleans, and strings are Python objects that have specific methods associated with them. Take the variable sister, for example, that represents a string. You can call the method capitalize on sister without any inputs. It returns a string where the first letter is capitalized now. Or what if you wanted to replace some parts of the string with other parts? Not a problem. Just call the method replace on sister with 2 appropriate inputs. In the output, Z is replaced with SA. To be absolutely clear, in Python, everything is an object, and each object has specified methods associated. Depending on the type of the object, list, string, float, whatever, the available methods are different. A string object like sister has a replace method, but a list like fam doesn't have this, as you can see from this error. Objects of different types can have methods with the same name. Take the index method. It's available for both strings and lists. If you call it on a string, you get the index of the letters in the string. If you call it on a list, you get the index of the element in the list. This means that depending on the type of the object, the methods behave differently. Before I unleash you on some exercises on methods, there's one more thing I want to tell you. Some methods can change the objects they're called on. Let's retake the fam list and call the append method on it. As the input, we pass a string we want to add to the list. Python doesn't generate an output, but if we check the fam list again, we see that it has been extended with the string me. Let's do this again, this time to add my height to the list. Again, the fam list was extended. This is pretty cool because you can write very concise code to update your data structures on the fly, but it can also be pretty dangerous. Some method calls don't change the object they're called on, while others do. So watch out. Let's take a step back here and summarize this. You have Python functions like type, max, and round that you can call like this. There are also methods which are functions that are specific to Python objects. Depending on the type of the Python object you're dealing with, you'll be able to use different methods, and they behave differently. You can call methods on the objects with the dot notation, like this, for example. There's much more to tell about Python objects, methods, and how Python works internally. But for now, let's stick to what I've talked about here. It's time to get to some exercises and add methods to your ever-growing skill set. Let's get you coding again.
Okay. Let's code again. Use the upper method to turn on place. Upper is not defined. UPPER. Ah, भैंस की आंख. ओके, सिंटैक्स ही गलत था. List methods. Use the index method to get the index of the element in areas that is equal to. Na, 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 na. Tuk, 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 tuk. Packages.
By
Pip3.
now, I hope you're convinced that Python functions and methods are extremely powerful. You can basically use other people's code to solve your own problems. That's amazing. However, adding all functions and methods that have been written up to now to the same Python distribution would be a mess. There would be tons and tons of code in there that you'll never use. Also, maintaining all of this code would be a real pain. This is where packages come into play. You can think of packages as a directory of Python scripts. Each script is a so-called module. These modules specify functions, methods, and new Python types aimed at solving particular problems. There are thousands of Python packages available from the internet. Among them are packages for data science. There's NumPy to efficiently work with arrays, Matplotlib for data visualization, and scikit-learn for machine learning. Not all of these packages are available in Python by default. To use Python packages, you'll first have to install them on your own system, and then put code in your script to tell Python that you want to use these packages. Datacamp already has all necessary packages installed for you, but if you want to install them on your own system, you can use pip, for example, a package maintenance system for Python. If you go to this URL, you can download the file getpip.py. Next, you go to the terminal and execute python3 getpip.py. Now you can use pip to actually install a Python package of your choosing. Suppose we want to install the NumPy package, which you'll learn about in the next chapter. You type pip3 install NumPy. You have to use the commands python3 and pip3 here to tell our system that we're working with Python version 3. Now that the package is installed, you can actually start using it in one of your Python scripts. Before you can do this, you should import the package or a specific module of the package. You can do this with the import statement. To import the entire NumPy package, you can do import NumPy like this. A commonly used function in NumPy is array. It takes a list as input. Simply calling the array function like this will generate an error though. To refer to the array function from the NumPy package, you'll need this. This time it works. The NumPy array is very useful to do data science, but more on that later. Using this NumPy dot prefix all the time can become pretty tiring, so you can also import the package and refer to it with a different name. You can do this by extending your import statement with as, like this. Now, instead of NumPy.array, you'll have to use np.array to use NumPy's array function. There are cases in which you only need one specific function of a package. Python allows you to make this explicit in your code. Suppose that we only want to use the array function from the NumPy package. Instead of writing import NumPy, you can instead write from NumPy import array like this. This time, you can simply call the array function like this. No need to use NumPy dot here. This from import version to use specific parts of a package can be useful, but you're also losing some of the context. Suppose you're working in a long Python script. You import the array function from NumPy at the very top, and way later, you actually use this array function. Somebody else who's reading your code might have forgotten that this array function is a specific NumPy function. It's not clear from the function call. In that respect, the more standard import NumPy as np call is preferred. In this case, your function call is np.array, making it very clear that you're working with NumPy. Off to the exercises now, where you can practice different ways of importing packages and modules yourself. You're well on your way to becoming a Pythonista data science ninja.
import the math package. Now you can access the constant pi with math.py. So circumference is 2 into general imports like import math. Make all the functions from the math package available to you. However, if you decide to only use a specific part of the package, you can always make your import more selective from math import pi. From math import radians. Calculate the distance import script as my inverted. Great. Okay, we'll drink one more water glass and then break or no break, I'm not sure. Like this last part will consume 2 hours instead of 1. So don't know. So another glass of water. It's almost 2 p.m. of December 12th, 1:43 actually. What does that mean? It means that I'll be coding till 4 p.m. and then Anu will be back and then I'll stop coding. So almost 4 hours of coding this will be. Okay, I'll walk around and be back. Like little bit of break. My eyes are tired. I'm not sure why this camera is on when everything is being recorded on this camera. In OBS, I'm sure I have disabled the other camera. Like, yeah, laptop camera is disabled. Still this camera is on. Not sure why. Yeah, that's my settings. And this is just headphone, no mic. Mic is directly from the laptop audio, wherever it is taken from. Okay, Hugo, let's get back to studies. Two hours 54 minutes recorded. Almost 3 hours.
Wow, you've done well. And by now, you're aware that the Python list is pretty powerful. A list can hold any type and can hold different types at the same time. You can also change, add, and remove elements. This is wonderful, but one feature is missing, a feature that is super important for aspiring data scientists such as yourself. When analyzing data, you'll often want to carry out operations over entire collections of values, and you want to do this fast. With lists, this is a problem. Let's retake the heights of your family and yourself. Suppose you've also asked for everybody's weight. It's not very polite, but everything for science, right? You end up with two lists, height and weight. The first person is 1.73 meters tall and weighs 65.4 kilograms. If you now want to calculate the body mass index for each family member, you'd hope that this call can work, making the calculations element-wise. Unfortunately, Python throws an error because it has no idea how to do calculations on lists. You could solve this by going through each list element one after the other and calculating the BMI for each person separately, but this is terribly inefficient and exhausting to write. A way more elegant solution is to use NumPy, or numeric Python. It's a Python package that, among others, provides an alternative to the regular Python list, the NumPy array. The NumPy array is pretty similar to the list, but has additional features, such as the ability to perform calculations over entire arrays. It's really easy and super fast as well. The NumPy package is already installed on Datacamp servers, but if you want to work with it on your own system, go to the command line and execute pip3 install NumPy. Next, to actually use NumPy in your Python session, you can import the NumPy package like this. Let's start with creating a NumPy array. You do this with NumPy's array function. The input is a regular Python list. I'm using array twice here to create NumPy versions of the height and weight lists from before, NP height and NP weight. Let's try to calculate everybody's BMI with a single call again. This time it worked fine. The calculations were performed element-wise. The first person's BMI was calculated by dividing the first element in NP weight by the square of the first element in NP height. The second person's BMI was calculated with the second height and weight elements, and so on. Let's do a quick comparison here. First, we tried to do calculations with regular lists like this, but this gave us an error because Python doesn't know how to do calculations with lists like we want them to. Next, these regular lists were converted to NumPy arrays. The same operations now work without any problem. NumPy knows how to work with arrays as if they were single values, which is pretty awesome if you ask me. You should still pay attention though. First of all, NumPy can do all of this so easily because it assumes that your NumPy array can only contain values of a single type. It's either an array of floats, an array of Booleans, or something else. If you do try to create an array with different types, like this for example, the resulting NumPy array will contain a single type, string in this case. The Booleans and the floats were both converted to strings. Second, you should know that a NumPy array is simply a new kind of Python type, like the float, string, and list types from before. This means that it comes with its own methods, which can behave differently than you'd expect. Take this Python list and this NumPy array, for example. If you do Python list plus Python list, the list elements are pasted together, generating a list with 6 elements. If you do this with the NumPy arrays, on the other hand, Python will do an element-wise sum of the arrays. Just make sure to pay attention when you're juggling around with different Python types, because the outcomes can differ a lot. Apart from these subtleties, you can work with NumPy arrays pretty much the same as you can with regular Python lists.
Okay.
When you want to get elements from your array, for example, you can use square brackets. Suppose you want to get the BMI for the second person, so at index 1. This will do the trick. Specifically for NumPy, there's also another way to do list subsetting, using an array of Booleans. Say you want to get all BMI values in the BMI array that are over 23. A first step is using the greater than sign, like this. The result is a NumPy array containing Booleans. True if the corresponding BMI is above 23, false if it's below. Next, you can use this Boolean array inside square brackets to do the subsetting. Only the elements in BMI that are above 23, so for which the corresponding Boolean value is true, is selected. There's only one BMI that's above 23, so we end up with a NumPy array with a single value, that specific BMI. Using the result of a comparison to make a selection of your data is a very common way to get surprising insights. Learn all about it and the other NumPy basics in the exercises.
Okay, your first NumPy array. Baseball option, import NumPy as NP. Import NumPy as NP. Create a NumPy array from baseball NP. Baseball, which is equal to np.base. Hopefully it works. Yes. Oh, print out type. NumPy ND array. What's next? Baseball player height. तो पहला कोड उसने लिख दिया. Import NumPy as NP. Create a NumPy array from height in inches. np.array function से height in inches. Okay. print np height in inches. Height in meters is equal to, because now I can directly use it, np height in inches multiplied by 0.0254. Print np height in meters. Yeah. Last time it took me a long while to get this code right. Create an array from weight LB with metric tons. Weight in kgs, which is equal to p dot array np weight in ओके कुछ गलत कर दिया. NP weight in LBS. Can I directly multiply it by 0.4535592? Will it work? I'll just check. print np weight in kgs. Okay, to comparatively we need to know what is weight in LB. Okay, I think it worked. Saying dot here, something wrong, I don't know. We'll figure out when the error comes. Calculate the BMI. BMI is equal to NP weight in kgs divided by, what is the divided by symbol? Slash. Or is there any divided by symbol? NP height in meters raised to 2. Print BMI. Okay, I think it ran. Yeah. Next, to subset both regular and Python list as NumPy. Okay, BMI तक का कोड लिख के रखा है. Create a Boolean NumPy array. The element of the array should be true if the corresponding baseball player BMI is below 21. Light. ये एक array है. BMI below 21 are light. Print light. Create a Boolean NumPy array. Oh, there is no NP. Oh, each element of BMI. Simple code. Print out BMI of all the players. ये NumPy side effects. ओह, ये सारे या तो स्ट्रिंग में कन्वर्ट हो जाएंगे या नंबर्स में कन्वर्ट हो जाएंगे. प्रोबेबली नंबर्स में कन्वर्ट हो जाएंगे. और ट्रू 1 होता है 3, तो ट्रू प्लस 3 4, 1 प्लस 4 5, 2 प्लस फॉल्स मतलब 0 2. तो ये होगा आंसर 4, 5, 0. ऐसा कुछ है. आई थिंक ये वाला सेम कोड देगा जैसा ऊपर वाला है. कंट्रोल C. यस, दिस इज़ द राइट आंसर. चेक करने के लिए हम बाकी वाले लाइन का कोड पेस्ट करके देखते हैं जो डेफिनेटली मैच नहीं करेगा. ये मैच नहीं किया. ये 4,5,1 है, पर हमको 4,5,2 चाहिए, इसलिए भी मैच नहीं किया. और ये तो डेफिनेटली मैच नहीं कर रहा. तो हमारा आंसर सही है. सबसेटिंग NumPy array. Subset NumPy weight will be by printing out the element of x50. Import NumPy as NP. Okay. Store weight and height list as NumPy array. NP dot array weight and LB को यहाँ पे सेव कर दिया बेटा. Print out the weight at index 50. Print np underscore weight underscore lp at index 50. Print out a subarray of np 100. Print out height. Index 100. जो 100 पोजीशन पे है वो तो 101 होगा या 99 होगा. 0 से शुरू हो रहा है, 0 से शुरू हो रहा है, तो 99 होना चाहिए. नाइन्टी नाइन से 101, सॉरी 111. पता नहीं सही है कि नहीं. ओके, सवाल ये इंडेक्स 100, ठीक है, 100 से 111 आ गया बस ही गया। 2D NumPy.
Well done, you legend. Let's now recreate the NumPy arrays from the previous video. If you ask for the type of these arrays, Python tells you that they are numpy.ndArray. NumPy dot tells you that it's a type that was defined in the NumPy package. NdArray stands for n-dimensional array. The arrays np height and np weight are one-dimensional arrays, but it's perfectly possible to create two-dimensional, three-dimensional, heck, even seven-dimensional arrays. Let's stick to two in this video though. You can create a 2D NumPy array from a regular Python list of lists. Let's try to create one NumPy array for all height and weight data of your family, like this. If you print out np 2D now, you'll see that it is a regular data structure. Each sublist in the list corresponds to a row in the two-dimensional NumPy array. From np2d.shape, you can see that we indeed have 2 rows and 5 columns. Shape is a so-called attribute of the np2d array that can give you more information about what the data structure looks like. Note that the syntax for accessing an attribute looks a bit like calling a method, but they are not the same. Remember that methods have round brackets after them, and you can see here that attributes do not. Also, for 2D arrays, the NumPy rule applies. An array can only contain a single type. If you change one float to be a string, all the array elements will be coerced to strings to end up with a homogeneous array. You can think of the 2D NumPy arrays as an improved list of lists. You can perform calculations on the arrays, as I showed before, and you can do more advanced ways of subsetting. Suppose you want the first row and then the third element in that row. To select the row, you need the index 0 in square brackets. Don't forget about zero indexing. To then select the third element, you can extend the same call with another pair of brackets, this time with the index 2, like this. Basically, you're selecting the row, and then from that row, do another selection. There's also an alternative way of subsetting, using single square brackets and a comma. This call returns the exact same value as before. The value before the comma specifies the row. The value after the comma specifies the column. The intersection of the rows and columns you specified are returned. Once you get used to it, this syntax is more intuitive and opens up more possibilities. Suppose you want to select the height and weight of the second and third family member. You want both rows, so you put in a colon before the comma. You only want the second and third column, so you put in the indices 1 to 3 after the comma. Remember that the third index is not included here.
Okay.
The intersection gives us a 2D array with 2 rows and 2 columns. Similarly, you can select the weight of all family members like this. You only want the second row, so put 1 before the comma. You want all columns, so you use a colon after the comma. The intersection gives us the entire second row. Finally, 2D NumPy arrays enable you to do element-wise calculations, the same way you did with 1D NumPy arrays. That's something you can experiment with in the exercises, along with creating and subsetting 2D NumPy arrays. Get coding, have fun, and see you back here soon. While I wait, I may even code a bit myself.
Go for it. Use NP array to create a 2D NumPy. मैं भूल गया कि it is print always I forgot. Use NumPy array to create a 2D NumPy array from baseball and name it NP baseball. अभी तो किया था. Create a 2D NumPy array from baseball. Print out the 50th row. Fiftieth row. All columns. रोज कमा कॉलम होता है ना. Make a new variable np weight lb. From 50 to all हो गया ये. 50th row नहीं हुआ. Okay. First column contains the player's height and second contains okay उल्टा हो गया. तो is to 50. नहीं. Remember that in Python element is at 50th row. The code can convert to 2D NumPy array is already first. The first column contains the player's height. Okay, सारे players height है. And the second column holds players weight in pounds, height and weight. इस तरह के 50 एलिमेंट्स हैं या ज़्यादा होंगे. ओके इसमें दो चीज़ें यूज़ होंगी. Yeah, all columns of 50th row. Select the entire second column of NP baseball. All rows after 0th column. Second column 1. All rows of the second column. अब सारा सेकंड कॉलम सेलेक्ट हो गया एनपी वेट के लिस्ट में. Print यहाँ पर हमने खोलता गड़बड़ की. एनपी बेसबॉल के ऑल रोज rows comma column. Make a new variable np weight underscore lb containing an entire second column np somewhere here. Row. If I click all rows and 0, okay, let's take hint. ओके ओरिजिनली ये भी गलत था, ये 49 होना चाहिए और 2 ब्रैकेट से ही कॉमा होता है. सिंटैक्स की गलती. तो नाउ यू नो इट इज all rows comma 1. Now print ना भी नहीं आता। इस लाइन ऑफ कोड की ज़रूरत नहीं है, इसे मैंने जानने के लिए किया। ओके, प्रिंट आउट 124th प्लेयर, 124th प्लेयर 123rd पोजीशन पे रहेगा ना। NP बेसबॉल के 123rd पोजीशन पे रहेगा। पहले कॉलम के भैंस की आँख। यार ये matrices always takes time. 2D arithmetics. You managed to get all the changes. And what you need to do, update it, add NP baseball and update it and print out the results. Print out. Oh, budgies. Print out addition of NP underscore baseball and update it. Conversion is equal to, और बाद में हम कन्वर्शन को मल्टीप्लाई करेंगे 0.0254 comma 453.592. Product of NP baseball multiplied by conversion. Hopefully ये सही है।
A typical first step in analyzing your data is getting to know your data in the first place. For the NumPy arrays from before, this is pretty easy because there isn't a lot of data. However, as a data scientist, you'll be crunching thousands, if not millions, or billions of numbers. Imagine you conduct a citywide survey where you ask 5,000 adults about their height and weight. You end up with something like this, a 2D array which I named NP City that has 5,000 rows corresponding to the 5,000 people and 2 columns corresponding to the height and the weight. Simply staring at these numbers like a zombie won't give you any insights, and zombies can't even interpret numbers correctly anyway. What you can do, though, is generate summary statistics about your data. Aside from an efficient data structure for number crunching, it happens that NumPy is also good at doing these kinds of things. For starters, you can try to find out the average height of these 5,000 people with NumPy's mean function. Because it's a function from the NumPy package, don't forget to start with np dot. Of course, I first had to do a subsetting operation to get the height column from the 2D array. It appears that, on average, people are 1.75 meters tall. What about the median height? This is the height of the middle person if you sort all people from small to tall. Instead of writing complicated Python code to figure this out, you can simply use NumPy's median function. You can do similar things for the weight column in NP-City. Often, these summary statistics will provide you with a sanity check of your data. If you end up with an average weight of 2,000 kilograms, your measurements are probably incorrect. Apart from mean and median, there are also other functions like core-coef to check if, for example, height and weight are correlated, and STD for standard deviation. NumPy also features more basic functions such as sum and sort, which also exist in the basic Python distribution. However, the big difference here is speed. Because NumPy enforces a single data type in an array, it can drastically speed up the calculations. Just a side note here. If you're wondering how we came up with the data in this video, we simulated it with NumPy functions. We sampled 2 random distributions 5,000 times to create the height and weight arrays, and then used column stack to paste them together as 2 columns. Another awesome thing that NumPy can do, and that you'll learn to do in the next course. Another great tool to get some sense of your data is to visualize it, but that's something for the next course also. First, head over to the exercises to learn how to explore your NumPy arrays. And so many congrats on making it this far. You've come such a long way.
ओके एक नया डाटा मिला है 1015 रोज का create a NumPy array. Create a NumPy array height that is equal to first column of NP raised by all rows first column, print out the mean np dot mean always remember to put the print thingy, which I forget. Wow. मीन 15,000 में है. Yeah, the average height is 1.86 inches. That doesn't sound right. However, median does not seem affected by the outliers. ठीक है. Both median and mean to get an idea of overall distribution. Okay. अच्छा, इसमें नन में हमको आंसर्स भरना है. The code to print out the median height is already included. Complete the code for median height. Replace none with the correct code. Print out the median. NumPy print mean height. Average is equal to NP mean. Print average. ठीक है. Median equal to NP MEDIAN of NP underscore baseball. Okay, height ही है तो all rows of the first column. Print out the standard deviation st np dot std with std of np underscore baseball all rows of first column. Print out the correlation between first and second. np dot co coefficient coefficient between first and second column. First and second column. Okay. Syntax क्या है? X, Y, none, R2, bias. Okay. First and second column. NP baseball का first column. All rows first column, comma NP baseball का all rows second column. इस पे मुझे घंटे लग गए थे लास्ट टाइम. ओके, ये बहुत ही ट्रिकी सवाल है. अगर कर पाओ तो वीडियो पॉज करके खुद ट्राई करो. इसको हम पढ़ लेते हैं ठीक से ताकि हम वापस समझें, क्योंकि मैं लास्ट टाइम बहुत अटक गया था इस पे. Okay, in the last few exercises, you have learned everything there is to know about heights and weights of our baseball players. Now it's time to dive into another sports, soccer. फुटबॉल को लोग soccer बोलते हैं. You have contacted FIFA for some data and they handed you two lists. The list are the following. First list is positions and second list is their height. For example, K is like goalkeeper, M is the midfield, A is attack, D is defense, that kind of stuff. So this will have multiple K, multiple M, multiple A on the first list of positions. Height, whatever height each person has correspondingly, respectively. Now each element in the list corresponds to a player. The first list positions contains string representing each player's position. GK goalkeeper, M is midfield, A is attack, D is defense. The second list contains height. That's all integers. The first place in the list is goalkeeper and he or she is like 191 centimeters, pretty tall. You are fairly confident that the median height of goalkeeper is higher than that of the other players on the soccer field. Some of your friends don't believe you, so you determine to show them using मैं दिखाऊंगा. You are determined to show them using data you receive from FIFA and your newly acquired Python skills. Convert height and positions, which are a regular list, to NumPy arrays. Call them NumPy height and NumPy positions. Okay. NP positions positions equal to np dot array positions np underscore heights is equal to np dot array heights or height. Height है कि heights है. Convert heights and positions. तो heights होगा. Height of the goalkeeper. Extract all the heights of the goalkeepers. You can use a trick here. Use np positions equal to gk as an index for np heights. Okay. gk underscore heights. ये बहुत ही मस्त ट्रिक है. उसने एक लिस्ट को यूज़ किया है इंडेक्स लेने के लिए और दूसरा पे वो इम्प्लीमेंट मारा है. तो ये किस तरह से करते हैं. gk heights एक वेरिएबल है जो लिस्ट है. that will be like it will have the value of np underscore heights. That means we'll be using the values in NP heights, but which positions we'll be using from positions. So NP dot means okay, from this array we'll be using the positions of NP underscore positions of everything which has GK. Probably I wrote the code wrong. GK heights equal to which is equal to double equal to means it's a expression. So we'll be using positions place but values of heights. Let's print this if I can to check GK heights. See, we have so many heights. Heights of other players. So other underscore heights is equal to NP underscore heights, value same, NP underscore positions which are not equal to के लिए equal to और लाइन लिखते हैं. ओके, लाइन और इक्वल टू लिखते हैं और GK. Single inverted comma, double inverted comma, Python doesn't make any difference. Next, print out the median height. Median NP dot median of GK heights. Here we will put NP dot median of other heights. And we got 188 or 181, so other players is more height. So you are fairly confident that median height of goalkeeper is higher than that of other players. Yes, goalkeeper 188 है और बाकी players 181 छोटे. Submit. इस कोड को बहुत टाइम लग गया था लास्ट टाइम, लेकिन बिकॉज पता चल गया. You have completed NumPy. तो कैरियर ही ख़त्म हो गया. इंट्रोडक्शन टू Python is complete. We did 100%. Ab complete. Now we can go to career tracks, and we have enrolled in data science. Hey, we can learn R from here as well. I think I should buy this Datacamp. Good for practice because I'll be doing R as well. But I think edX has a connection with Datacamp, so whatever I'm doing it at edX, I'll be using IPython designed by these people only. Means what the course inside is built that I'll be using Datacamp anyway. So if I'm paying for that edX thing, I'm indirectly paying for Datacamp. But this is more organized, but has no certificate. Like the certificate is not accredited. It has a certificate just to show off kind of stuff. So this completes the introduction to Python. Let's get back F11. Finally, if you need to continue or if you want me to make more videos, kindly subscribe. And if I get like overall 1,000 subscribers, I'm on 500 right now. If I get like 1,000 subscribers, I will continue this track. And what does this track have? Come on, show me. This track has, after introduction, intermediate in Python, then Python programming skills test, and then one project, then manipulation, then there are like 23 more things to go, like we discussed in the start. So please subscribe. If I get 1,000 subscribers, I would definitely come back and put that hard work to code further, and simultaneously you can practice that as well. Hopefully I didn't use any music except the ads which I was watching on my mobile in my breaks. And hopefully Datacamp don't put a copyright strike over here. But overall, I'm happy to contribute more in this thingy. But for the next few weeks, I'll be focusing on this course more. Cheers. See you next time in next video or next live, whichever is earlier. Ciao. Bye bye.